last class, you sent me a copy of that. Is that right?
Yes, I did.
I'm thinking.
Professor Wickman,
Yeah.
have you taken roll?
Pardon me?
Have you taken roll?
Oh, no, I'm working on something though.
Oh,
Second.
okay.
Second. Let me do it like this. Hmm. Almost finished. No. All right, Lizette, are you still there?
Yes, I'm here.
I just sent you a review, and you and I talk about it before, so we can be sure that we covered it, right?
Yes.
Before I send it out, I don't want to send it out to everybody because I want to go over one or two people. You or possibly Jerry. Let me, because there's no sense in everybody all concerned about until I got it all figured out. All right, so what have I missed in terms of someone else came on?
Professor, did you call me already? This is Sam.
I called a bunch of folks, but if you won't recall me, then you should tell me. Well, Stella, I have you now. Who else?
Did you get Maria?
Thank you.
Maria Alvarado, I do now. Who else?
Okay.
Angela Humber.
Angela, let's see, Angela. Let's see here.
I'm here too, sir.
Hold on, let me make sure. Hold on. I don't get messed up here. Angela, why don't I ever find you?
You said I was at the bottom of the page now.
Oh, yeah, you're supposed to remind me. Yeah, there you go. Okay, then Brianna,
Yes, sir.
you're good. Who else? Justina. Justina, I did call you. You're good. Mariella,
I'm here.
gotcha. You're good. So let me just go over the names I don't have. I do not have Ulissa Alvarado.
I'm here.
You are? Good
Yes.
deal. Naomi? No, Naomi? Giselle? Tamara? Here. Ashley, you're here. Alicia Romero.
I'm here.
Yeah. Thought so. I asked you, I think, you and all those 4 children there. How about Gift? Are you here? No Gift?
Yeah, I'm so sorry. I forgot.
You forgot what, that you were here?
No, I forgot that we had a today.
Sure, I marked you in. Daniel Ramos? No Daniel? And no April Sierra. So I'm hoping, and no Isaiah Green. Hoping that, Jose, that you're still sending these out to people. Okay. Good deal. All right. So, Lizeth, you had a chance to look at that a little bit.
Yes, I have.
Any of it look like we covered any of it?
The last 17 through 20, we haven't. And number 9, I don't think we've covered it.
Let me look at that real quick here. I think I printed that.
I think the rest we've done on that first page, on that first exam.
Number 9. Yeah, I think we've done number 9. What other one? But we can go over it again. And the other ones, what through what?
17 through 20.
Did we do 21?
21. No, we haven't done 21 either.
Okay.
The log X, no.
Other thing, we could put one other thing. What the? Why? Something seems weird. What was your first problem on that, Lizette?
On this one,
On your thing I sent you?
12X,
Okay. That's all I need to hear there. All that. And okay. Oh, I don't show. One more second, class. This kind of got a mess up here. I want to be sure that I do the right thing. Did you guys hear me print anything while I was on here? If I'm losing myself here. I think I've got it figured out. It's coming out now.
oh, and we haven't spoken about the imaginary numbers. Well, you have, but not like number 2.
Okay. All right, I got an idea. Okay, we're back in business. Mary Ellie, did you have a did you have a question?
No, sorry. It was an accident.
No problem. I just want to be sure we're good. Okay, so I think I'm all set up, believe it or not, after all that. I already have the book in hand, so let's go to that. You should be able to see the book now. You all see that? Example one.
Yes.
Yes.
Okay, so we're going to talk about examples of symmetry for x squared plus 2. Now, this is a very simple graph. You guys probably don't realize you've done it, but let's just take a stop for a second, quick here. Let's go to our calculator. Let's simply go to turn it on. It's sleepy. And that's what it looks like. This is x squared. Now, that's in the form of y equals x squared. That's how we graph things. Now, the one we have in the book is the same thing. Only we're going to add plus 2. So all that does is shift the graph up 2 spots. That's all it does. Doesn't do anything else. This will be our red graph. We'll graph it. So you can see it there. It's just 2 points above the blue one. So this is symmetrical with regard to the y-axis. To make sense, it's mirrored. What you see on the right is the same thing on the left. It's the opposite. So let's go back to the book. So they're looking at this visually, showing you that it looks symmetrical. And we just graphed it ourselves. It's pretty simple to graph. And anytime you want to well, we won't talk about that. We'll do that today. But anytime you guys have a question with the graph, you should graph it. Now we have test x squared plus y for symmetry. Now, if we put this in the calculator, we have to do it in terms of y equals. So what we normally do for symmetry, we just put in test points. Now, they tell you the algebraic way to do it is change the y and put a negative y in there. Does it change the outcome? The answer is no. So if you look at the x-axis, or you just look at the diagram, there is no change. So it's obviously symmetrical, probably with regard to the origin. They say with regard to the x, they say with regard to the y, but some professors would say it's symmetrical with regard to the origin at 0, 0. And why? Because if you put a negative in for it, it has no effect. Same exact answer. Now, even in odd functions on the test, and then they'll also give you an option of neither. So it's instead of an A, B, C, D choice, it's A, B, C. So an even function, that is when you put a negative x in, it doesn't change it. If it's symmetrical with respect to the origin, it's an odd function. So they're going to give you some pictures of some. I mean, we don't even need to do pictures. I can just show you. Maybe it's easier. Let's go to this. So look, if I draw this graph like this, that's an even function because it's symmetrical with regard to the y. Marielle, your hands just keep popping up here. So that's that one. This graph is
Professor,
yes.
my phone is cracked, so that's why it keeps on like clicking on the hand.
What can I do about it? It's covering my stuff.
What? It's because I would have to like log out because I'm on my phone, so it keeps on doing that.
All right, I'll work around it somehow.
I'm sorry.
All right, well, I'd rather have you stay. Okay, now, this is symmetrical with regard to the y. Everybody see that? Does that make sense?
Yes.
So now let's do this one. This is symmetrical with regard to the origin. There it is like this. The other one I'm going to draw looks like this. It's neither. So that's all they're going to try to talk to you about right now in this part of the course or text. So look, you can see this one here is symmetrical right in front of you with respect to the y. It shows it. This one is neither. Oh, excuse me, with the origin. Huh, not bad. So it's odd. It is an odd looking one, but it is symmetrical. I'm looking at it. And let's see if they do neither. Well, neither. Let's see what a neither would be. Number 5. Number 5 would be a neither. Now yours are going to be simple. Yours will be something like number 1 or number 2 or number 4. Something similar. 33 is easy too. Okay, so there you go. Let's move on. Our next chapter is 7.2. Is that any page we have for that?
It's page 446. Transformations.
Thank you. Is that Lizeth again?
Yes.
Yes. 446 coming into it. Number 1, graph each of the following. Before doing so, describe how each graph can be obtained from one of the basic design. We already did x squared, so we know it just goes down 6. We know that this thing here is symmetrical with regard to the y, so that's part number 1. Let's go to example number 2. X plus 2, a square root. A square root can always, can never be negative, but it can be 0. So this thing would start at -2 and go on. Let's just graph it, square root of x plus 2. Let's see this. I hope it makes sense to you. Enough on. Go away from. We said we're going to, let's put that on. Put that one on. Square root. We're going to do second square root of x plus 2. Now let's examine this before we do it. What makes that in square root 0? That's if x is -2. So at -2, it's 0. At -1, it's 1. So we know at -2, this is where this graph will start. At -2 is 0. Because if you put a -2 in there, the square root of -2 and 2 gives you a square root of 0. And so the x is equal to 0. So y equals, if x equals -2, y has to equal 0. We'll just graph it. It'll show you. There's your -2, 0, right where it starts. It's always going to be that way. Now, you can't go any further. You can't go to the left or, down because that's negative.
Professor? Oh, on my calculator, when I try to hit graph, it gives me an error message for the window range.
You have a calculator like this?
Yes, and I think I messed up like the numbers, I think.
No, probably not. Who is this?
It's Naomi. I came in late.
Naomi. So let's look. Click on your Windows button. That's this one. You see where I'm pointing?
Mm-hmm.
Click on it. Make it read that.
Oh, okay.
That's your mistake. Don't doubt that that you put in the wrong stuff.
Yes, for the X, for the first one, I had positive 10 instead of negative 10. Okay,
So,
it
is that
works.
helping you? So Naomi, you're here. I'm going to mark you in.
Yes,
Good deal.
thanks.
Did you graph it now?
Yes, I can see the graph now.
Did it work?
Yes.
Okay.
Thank you.
Now let's go back. Book. Well, we did see D will be the same thing, except for it will go down 3. Let's just do it one more time. We're going to use the same graph. We're going to go to the same machine, same calculator. Still should be lit up there. Let's see if it is. And we're going to just go over there and at the end of it, put -3. This, 3. And see what happens. Actually, you know what we ought to do? Let me see if I can do this. Let's leave that. Let's do the red one. Let's do the same thing. But let's get a different picture. Sorry, I just want you to see the differentiation of it. I mean, I could easily have done the other one, but easier for me too. But I do want to give you the best bang for your buck. And what did it say? Minus what? 2 or 3? Was it -3? Does anybody remember?
Yes, -3.
Yes, sir. Minus 3.
So we're going to graph it. Let's see what happens. There's the original graph. That's the first one we did. Now here comes the second one. Down 3. That's right. It parallels it. Symmetrical. All we did was we made it lower. Pretty cool. So you guys should now start to be understanding your graphs a little better. Or your calculator too. All right, let's go to the next one. Gee, we spent all that time on that one. I'm sorry. That was number 1. Well, I think that was good though. You got a chance to see it. Look at this graph here, just for the fun of it. Notice that you have the absolute value. That's the dark one. Now, if we say x minus 4, what makes that package 0? Inside there is moving it over 4. That's positive 4 to make it go over to 4. If we want to make it go over to the left, we would put in a positive 4, x plus 4, because then it would take a negative 4 to make it go. So there you have it. That's that one. You already did this one. We showed what happens there. Let's go to graph each of the following. Before doing so, describe what you're supposed to see. We have f of x equals x cubed minus 4x squared. And that's going to be the black line. Now, if we put a negative in front of all of those, making it a negative x cubed and a negative negative x squared, you'll see it just changes as shown in the graph right here to your left. All they're pointing out is that when you change the sign, you're going to get a reflection. That's all they're pointing out. Nothing more. Number 3. Now, this is kind of unique. And I'm not sure I like the way the book teaches it, but it's counterintuitive. So hopefully this will make sense to you. So look at the first graph you see here. The basis of it is x cubed minus 3. But when we multiply it by 1/10, it doesn't get smaller. It stretches it out more. Now let's go over to the y one. -2 makes it go up faster, makes it skinnier, and changes the direction. So you're having three things here happen. Number one, it makes it go up slower when you that's counterintuitive. It stretches out. But you would think if you multiplied by a larger number, it'd make it wider like it is. But in fact, it's the opposite. When you multiply it by a fraction, it stretches it out. The green one, when you multiply it by 2, it gets faster up. And then the negative, it just switches it, and that's the reflection. That's called vertically stretching and shrinking. So the answer to a question is what would make it stretch out more? That would be using a fraction. Okay, now, I don't like how they show these. But at the left is a function, and they have 2f. All they're saying is, if you multiply it by 2, what's going to happen? Well, it's going to get faster, it gets skinnier. Now, do they show that? No, not really. They show it as 2f. Go to the next one. Now, the green one is multiplied by 1/2. Notice it stretches it out. I'm giving you really two graphs here, class. This is, don't think this is an equation. It's not. There's showing you a left-hand graph and a right-hand graph, two different things all together. On the left-hand side, when you multiply half, it stretches it out. On the right-hand side, the green, it stretches it out. On the left, where it's yellow, you multiply it by 2 versus 1/2. It gets skinnier, and both of them do. That's all they're trying to say. This is stretched out by 1/2 here. There you go. Let's go to the next one. So all you've learned is what happens. So using the graph of f of x, show at the left of the graph what happens here. So look, this is what you have. You have two different graphs. You have this little triangle thing here and this little polynomial. Now, this is just the regular graph. It says y equals f of x. Look up in the left-hand corner. Then we're going to morph this. It's called morphing. We're only going to do one portion of it. We're going to multiply it by -2. So that means both these things are going to stretch out. Let's take a look at number 2. Number 2, stretched out. Look at how much it stretched out. Or it got skinnier, excuse me. I misinformed. It got skinnier because you multiplied by 2. So the triangle squeezes in, goes up higher, faster. Look at the polynomial. It drops down deeper, it gets skinnier again. Now, we're going to add, what does it say up here? +1. It's going to make it move. There's your +1. Now, they also tricked you here. They also multiplied this by a -2. And it moves everything. In which direction did it move? It moved it up 1. So look at the green one, which is the -2 times x minus 3. And when you add 1, it just pushes everything up 1. So look at the red portion of the triangle on the right. It simply went up 1. If we made this 2, it would make it go up two spots. This is a really, I hope that helps you see what they're trying to tell you here. If it was a minus, it would go down. All right. So the question is this. If I have an equation of simply x squared equals 1, if I change it by doing this, if this is the original graph, is the new one going to be like this or like this? If this is the original, this is A, this is B. When we multiply it by 2, are we going to get A from the original or B? Anybody? This is what we're supposed to have learned. No, you'll get A.
A.
It goes faster. So if we have a graph like this, and that is x squared, and we multiply it by 1/2, it's going to stretch it out like that. 1/2 makes it go up slower, half as fast. And to complete this concept, if this is y equals x squared, if we change this y equals negative x squared, what are you going to get? Does anybody know?
It goes lower or down.
Like that. The opposite. Let's see if we're right. Let's see. You can always test it. That's the cool part. And that's, yeah. There you go. All right, so we're going to go up there to our turn graph chronicles. I'm going to clear that one out. Put it in the center. Look up there. We're going to write x squared. Push it out and graph it. Good. There it is. Now, let's see once what will happen if we put a negative in front of it. Go red, I like the description. We're going to put a negative sign, not the minus sign. This is the negative sign right here. Same thing, x, upper arrow squared. Push it out. We're going to graph this one. Here, it just reflects it. That's all you've learned, supposed to have learned so far. But it's a hard concept. But hopefully it makes sense. I tried to bring it up. I can share with you, I've had students look at those graphs forever, and almost 90% of the time, they come back and say, Dr. I don't know what they're trying to tell us. So hopefully this time we're good.
So will we have something like this on the test? And do we have to multiply each step?
Good. Can I call you back? I'm on a lecture right now. I will call you as soon as I can. I'm in class. I would think that this group would want to get out of here in about 35 minutes. But sorry, group. I thought that was important, and it was. So what's the next page you said?
It's 458.
Thank you.
You're welcome.
I miss any other questions? So you guys know, for the midterm exam, you'll be given the opportunity to go over every one of the problems that's on the exam. And in addition to that, it'll be a take-home exam. And if you don't score above 90, I'm going to be not happy. Because the only time a student doesn't score good on a take-home exam because they just didn't take it serious. And this is a chance for you to score, I believe, 110 points on a midterm. All right, the complex number system. In a nutshell, this is what it looks like. I equals I squared equals -1, I cubed equals a negative I, and I to the 4th power equals a +1. This is the one we use the most. I squared equals -1. So I would box this up, make sure you had that, or memorize it. It's pretty quick. Are there any questions about the imaginary numbers so far?
No.
So look, here's how you would use it. So if I have the square root of a -4, that's equal to the square root of a -1 and the square root of 4. They equal each other. Now, most folks then would rewrite that as 2 times the square root of a -1, because 4 is the number that you know, the square root of. Now, -1 is not able to be rooted. So we change that to I squared. Now we all know, since this is a square here, if this number matches this number, we'll get whatever's inside, so it's 2I. So in other words, in blown up portion, that's a 2 here, this is a 2 here. If these two numbers match, you get whatever's inside. So that's what this whole chapter is about. Now, if someone would just start out with like this, I think it'd be better. But let's go to the book now, because I think it'll make more sense. I think it will. All right, so they do the thing with -7. They do this thing with -16. -16 is the closest to what we did. We just need to do one of those. Let's go to that and see it. It's going to be the square root of 16, then the square root of -1, if they show it correctly. There's B. And then they take the -1, and see, they don't really show you how they get from -1 to I. They just say, oh, it is. And then they put the 4 in front of it. The rule is, in fact, this is not even correct. The rule is this. We said for our answer we had 2I. This part is called the imaginary part. In fact, the answer is this: 0 plus 2I. There was no number in front of it, so this is the real portion, and it is a 0. This is the imaginary portion right here. A lot of folks don't know that. So the correct answer really is supposed to be 0 plus 2I, not just the 2I part. So somewhere along the line, they'll probably straighten you out and mention that and fix themselves. So that's 48 is the same thing, except that they break it down a little more. 48 is the square root of 16 times 3. So the square root of 3 stays in the root. The 4 goes in front of the I. And so we have 4I times the square root of 3. And the I, don't look at the second part here. The I is technically on the outside of the square root. It's not inside it. I don't know. I would never do that. But that's a way to do it, but it just confuses folks. The I is not under the root. I like the left better, but I'll take whatever you give me. Now, these are numbers, imaginary numbers, complex numbers. Notice that in an imaginary number, they don't just put the BI, that's the imaginary part. They give you the A in front of it. And I gave you that answer was a 0. So again, this is just the imaginary number system. Don't pay attention. All you got to do is remember I squared, I cubed, and I to the 4th power. You all know what your rational numbers are, rational numbers and stuff like that. All right. So now we're going to do adding them. I mean, look, 8 plus 3, duh, is 11. 6I and 2I gives you 8I. And that's all you do. That's the answer. 11 and 8i. I'm not going to waste your time with number 2. I mean, duh. Let's go to number 3. So we have 2 parts in number A. For the square root of a negative 16, the square root of negative 25. I'm going to do that one for you. See here. I'm getting a lot of music and there we go. So, somebody's talking.
Oh, okay.
So I'm saying okay. All right. So I was going to show you the square root of what was it, 2i? I just remember what I lost my
Square root of negative 16 times square root of negative 25.
Yeah, that's right. But you're on target with that. This is the square root then of negative 1 times square root of 16. This is times the square root of a negative 1, the square root of 25. We know that negative 1 is I squared. We know that 16 is 4. Again, I squared. And 5. Now here's the tricky part. This becomes 4i times 5i. You take the square root, but 4 times 4 is 20. I times I is I squared. I squared is in fact a negative 1, so the answer is a negative 20. And 4i times 5i, 4 times 5 is 20. I times I is I squared. But you remember, I told you, most important one, remember, is I squared is a negative 1. So negative 1 times 20 gives you negative 20. And let's see if that's what they give us. Let's check. And there it is, your negative 20. Now, I want to do another one, B. B is the same as C. Well, let's do C. It's supposed to be a little more complicated. 3 minus 7i squared. I've got so many notes written down here, so I make sure I don't lose that again. Make notes myself to try to clarify things, make sure it's kind of scatterbrained, I guess. 3 minus 7i, and we said it was squared, so that means you're going to multiply it by itself. So all I've done is taken the liberty to show it like this. Now, use FOIL system. We take the first ones, 3 times 3, you get 9. They take the outer ones. 3 times that gives you a minus 21i. You take the inner ones, you get another minus 21i. Then you take the outer ones. That's a negative 7 times a negative 7 is a positive 49i squared. Now this stays 9. This becomes a negative 42i. 49 times I squared gives you minus 49. If you add 9, you get negative 42i. And if it's written correctly, you put the 40 in front of it here. So you get 40 minus 42i. Again, we combine these. Those is simply a negative 49 and 9. That gives you a fraction of minus 40. And a minus 42i stays. This is in the form of a plus bi. So let's see if we're right. Hopefully we are. jump down to number 7. Negative 40 minus 42. Exactly right. So just C is a good one. This is often one that you'll see on the test. It's a matter of keeping it straight. And you all know if you have any questions at any time, you can hammer me and say, what's going on? Now, example 4. Example 4 tells you to simplify all these. So let's just make up our own and start that making it simple. I to the 4th power is 1. Now, if we start out with the first one, I equals I squared equals a negative 1, I cubed equals a negative I to the 4th power equals positive 1. What it does, it repeats by dividing by 4. So if I say, what does I5 equal? We start over again. It's equal to I. You would subtract 4 from it, and you'd have I to the 1 power. Okay? I to the 17th power. In increments of 4, you'd have 16, so that would equal I again. Why? Because 17 minus 16 gives you 1I. 18, I to the 18, will give you I squared. But I squared is equal to a negative 1. I hope you're getting the pattern. So, if I say I have I to the 35, if I take 32, I give left over, this gives you I to the 3rd power. This is equal to a negative I. Why? Because 35 minus the largest increment without going over 35 is 32. That's 8 times 4. Gives you 3 left over. So that's all they do. Is there a question? So somebody tell me, what would I to the 41, 42 be? Tell me what I to the 42 equals.
Negative 1.
Yeah, because it becomes I squared, and that's equal to a negative 1. Yes, it's great. Is that Lizette?
Yes.
All right. So, Brianna, love me again, love me. Let's go back to the person again. So look, that's all they do. So 80 is an even number, so what is D going to equal? 1. I think we did 37, it was I to the 3rd power. That's equal to a negative I. There it is. The conjugate of a number. But just change the sign. If you have negative 3 plus 7i, the conjugate is negative 3 minus 7i. I mean, gosh, so simple. And we'll see it right here. I don't want to oversimplify it, but look. And why do you do that? You multiply things by the conjugate. Why? Because the middle terms drop out. So look, they give you 5 plus 7i. Let's make this one easy. So they give you 5 plus 7i, and the conjugate is 5 minus 7i. And we're going to multiply it. So 5 times 5 is 25. 5 times that gives you a minus 35i. This times this gives us positive 35i. Notice they cancel. And then you have 7i times 7i gives you a negative 49i squared. The I squared is a negative 1, so you have 25 plus 49, which is going to equal to 74. I think that's right. Let's take a look. There it is. 74. Positive 74. 29 plus 49, 74. To divide something, you just put it upside down, underneath it. Now, here's the deal, though. Look at what they did here. The first part shows division, 2 minus 5i or 1 minus 6i. But you cannot have an imaginary number in the denominator. So you multiply it by what? By the conjugate. So you know the middle terms drop out. So you're going to have 1, and 6 times 6 is 36, so you get 37. And no, it's easy. The top part is a little more complicated. You got to take 2 times 1, and 2 times 6i, then 5i times 1, then 5i times 6i, and so on, and you get the answer 32 over 37 plus, actually 32 plus 7i over 37. You can break it down and make it look like the second. The answer right above the bottom line is good for me. You can separate out anything. So for example, in this case, again, as with any problem, if I have 4x plus 3 all over 2, that's the same thing as saying 4x over 2 plus 3 over 2. Then, of course, you can make this to be 2x plus 3 over 2. That's all they're showing. A better example would be 3x plus 3 all over 2. That could be 3x over 2 plus 3 over 2. That's all we're showing. Same thing. Well, class, that's it for today. I hope that you felt like it was informative.
Yes.
I really think that these meetings are helpful. Let me go over the roll one more time just to make sure I've got everybody accounted for. Did Giselle or Tammy make it? Giselle, did you make it? No. How about Brittany Houston?
I'm here.
Good deal. You okay, Brittany?
I'm good.
All right. I think that's the only, no, wait a second on the page here. I'm not accounted for. Let's see. April Sierra's not here, and Gerardo Ramos. Everybody else accounted for. Good day. All right. Any other questions of me? Let me, before Alicia, let me speak with Lizette before we finish. But Alicia, what's up?
Who? Me?
Yeah.
Nothing.
Okay. I just saw your mic come on, and I thought maybe you had something.
Oh, no, all is good. So
Jerry,
are you
you
sending
good?
us the midterm yet? No, not yet.
When I review it and make sure it's right, I will.
Okay, will do. Gracias. Have a good night.
Thank
All right.
you.
See you guys. Stay warm.